This is Algebra 1, Semester 2. It's the 5th unit called Equations Review, and it's the 7th lesson called Variables on Both Sides of the Equations Practice. It's on creatormath.com. It's under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find it. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages. So just to preview the notes for you really quickly and how to find those. Here's the name of the website, creatormath.weebly.com. Google that. Here's the home page. Looks like this. Any questions you have about your composition book, scroll down until you see the words composition book and go ahead and watch all the videos, follow the directions, and follow the deadlines. You should have a 90 or 100% on your comp book. Let's go to Algebra 1 tab here. This is a PDF with all of your vocabulary. If you're not getting 100% on your vocabulary practices, maybe you don't know, but there's a PDF you can download to your computer and search it for the words that we're studying all throughout the year. So this is semester 2 we're in. We're looking for, if you haven't copied this table of contents on the pages 2 through 6 of your composition book, please stop what you're doing and do that now. Let's scroll down until we find Equations Review. So here's Equations Review. This is unit or lesson 7, variables on both sides. Here are the pages it goes on in your comp book. These are the notes. We're going to click right here. Please don't use this as the determining factor of what those pages are, but go back and find the original table of contents at the time you're viewing this. These page numbers probably will be different by then. If we open notes, and sometimes it takes me a couple of times, but you're going to copy these problems into your composition book on those pages and try to follow along. And that way when you do the actual problem set now and watch this video, hopefully it makes a little bit more sense to you. Here's one with no solution, by the way, 0 on both sides. Vocab, variable, equation, smaller number. We want to subtract the smaller number of x's from both sides. I'll show you that in a minute. Break-even point is the point at which benefits equal rewards, right? It's the 0 point. So if we spent $300 starting a business and we made back $300, we'd be right back at 0. That's the break-even point. Once we made $301, now you have $1 in profit. That has now gone beyond the break-even point. So those notes will help you do these problems. This looks a little messy right off the bat. Let's take this down to here. Let's go 4 times x plus 7 equals 1/7 times 21x plus 21 there. Can I still see this? Yes, it looks like I still can. So let's distribute first. This becomes 4x plus 28 equals 1/7 21x plus 21. I don't like a 7 in the denominator, so I'm going to multiply the whole thing by 7 over 1. That's going to multiply a 7 here, a 7 here, and a 7 here. The 7 here is going to cancel and disappear, and we're going to be left with only this on the right side. So we're going to be left with 21x plus 21 on the right. 7 times 4, 8 is 28x. Plus, and 7 times 28, don't be afraid to just jump right in there, open up your calculator, and let's say 28 times 7. 196. All right, notice we have x's on both sides of the equation. That's the point of this lesson. So we're going to take the smaller number, 21x is here, and 28x is there. We're going to subtract 21x from both sides. All right, that's going to disappear here. 28 minus 21 is 7x. We have a plus 196, drops down and equals right in the middle, and a 21 on this side. We're going to subtract 196 from both sides. Disappear here, so we have 7x on the left. And we have 21 minus 196, negative 175. And if we're lucky here, 175 will divide evenly by 7 on both sides. It's a little bit higher. Divided by 7. And it equals negative 7. That can't be right. Let's clear this. And go 175 divided by 7, 25. There. A little bit better with that. So that would be 49 if it was 7. So it's a negative, so we have a negative, and we have 25 in here, all right? So what do we got here? Negative 25 is x. All right, so we've taken up a lot of space, but let's keep going. We've got enough here. We can probably work around this. Let's rewrite this one. This one is 1/3. Maybe I can be a little bit tighter in my writing here, not so messy. 3 equals minus 2 times x minus 8. All right, distribute first. And in this case, I am going to distribute because notice there's a 3 in the denominator. That's going to divide evenly into the 9. So 1/3 times 9x is 3x, and 1/3 times 3 is plus 1 because it becomes 3 over 3, or 1. This gets distributed across its two values, so negative 2x and a plus 16. The smaller number of x's I'm going to subtract from both sides. In this case, I'm going to add this to both sides, so plus 2x on both sides. There's a 16 over here and equals, there's a 1 still, and a 5x. I'm going to subtract 1 from both sides. And I'm going to get 5x equals 16 minus 1 is 15. Divide both sides by 5. And x equals 3. Okay, there it is there, and here it is here. All right, did I make up a little bit of space? Took up quite a bit of space there too. Let's go to the next. Let's rewrite it. X minus 10 equals negative 3 times x minus 2. Let's distribute. Negative 3x. Negative times negative is positive 2. 3 times 2 is 6. And x minus 10. I'm going to add 3 x's to both sides. And since this is a review unit / lesson, I'm going to do two things at once. I'm going to add this 10 to both sides. I wouldn't do this if it was our first time going through. I'd go slower here. What happens? The 3x's disappear here. 3x and an x is a 4x. The 10's disappear here. The 10 shows up here as 16. Divide both sides by 4. X equals 4. All right? So I'm not happy because I don't see an x equals 4 there. Let's see, x minus 10 on this side, a negative 3, x minus 2. So negative 3x plus 6. I'm good with that. Let's see, add 3x is 4x. Add 10, and I get 16. 16 divided by 4 is 4. I like x equals 4 here. I'm going to drop in x equals 4 right here. All right, that's going to be the answer when we go down through this. Let's move to the next one. 3x minus 2 equals 5x plus 2. So the no distribution here at all. Let's subtract the smaller number of x's from each side. So I'm going to minus 3x from both sides. And I'm going to come over here and subtract the 2 from both sides at the same time. Keep everything lined up. These disappear. This becomes negative 4 because negative 2 and negative 2 is negative 4. 5x minus 3x is 2x, and these 2's disappear. If I divide both sides by 2, it now looks like this disappears, and x equals negative 2. Negative 4 divided by 2. 4 divided by 2 is 2, and a negative divided by a positive is a negative. So x equals minus 2. And you can flip this and say x equals minus 2 right here. Right? Let's do one more on this page. Negative 5 times negative 4x minus 2 equals 4x minus 7 times negative 3x minus 10. Wow. Two sets of distribution. This becomes positive 20x positive 10 equals 4x. This becomes positive 21x. This becomes negative times negative positive 70. All right, let's see if we can combine like terms. 21x and 4x is 25x plus 70 on the right here. And 20x plus 10 on the left. Let's subtract the smaller number of x's, 20x in this case, from both sides. Let's go ahead and subtract the 70 from both sides. Okay, 70's disappear. x's disappear. 25 minus 20 is 5 x's on the right. Negative 70 minus 10 is negative 60. Divide by 5 and divide by 5, and it looks like negative negative is a positive, unless I'm missing something here. 1 minus 25. Looks like a positive 12 to me. Well, no. You're dividing by positive 5. There we go. 60 divided by positive 5. So I'm going to get a negative 12 equals x. There we go. Okay, happy about that for the moment. Let's see how many more I got. All right, negative 4 times negative x minus 4 equals negative 4x plus 6 times 2x plus 6. Distribute this. Negative negative is a positive. 4x, negative negative is a positive. 16 equals negative 4x plus a 12x plus 36. So 4x plus 16 equals, this is 12x minus 4x, which is 8x plus 36. Let's subtract the smaller number of x's on both sides. That'll disappear the x's from the left, put them on the right. So let's subtract 36 from the right. Do the same thing to the left. These disappear, these disappear. We're left with 8x minus 4x equals 4x. And negative 36 plus 16. Right, 20. I don't know why I need a calculator for that. Negative 20. And 4x equals negative 20. I'm going to flip it, divide both sides by 4, and get x equals negative 5 in this case. All right, so far so good. Negative 2 times x minus 6 plus 2x equals 3 times negative 3x plus 10. This being multiplied across here and here. Negative 2x plus 12, because negative times negative 12, plus a 2x drops down. This is a negative 9x, and this is plus 30. These two x's cancel. Look at that. So you don't have x's on both sides. You've got 12 equals negative 9x plus 30. Let's subtract 30 from both sides. Gone. Negative 9x equals, so it's like a negative 18 here. So negative 9x equals negative 18. So looks like what we got. Divide both sides by negative 9, and x equals a positive 2. Right? One last one. We've got 6 times x plus 7 equals 5 ninths. 27x plus 27. Distribute this side and get 6x plus 42 equals 5 ninths times this 27x plus 27. The 27, the 9 divides into both these, right? So I'd be tempted to not multiply through by 9, but just multiply through by this one across both, and let's see if we can get them to cancel out. So you got a 5 times 27x over 9 plus a 5 times 27 over 9. So 9 goes into 27 3 times. So this disappears and this becomes a 3x. This disappears and this becomes a 3. So we've got 6x plus 42 on the left. Can I still see this? Yes. And I've got 3 times 5. So 3x times 5 is 15x. And 3 times 5 is plus 15. Subtract the smaller number of x's from both sides. So we're left with 9x here, plus 15, plus 42 on the left, minus 15 on the right, minus 15 on the left. 9x equals, so 42 minus 15 is 25. 27. 27, divide both sides by 9. And 27 divided by 9 is 3 equals x, or x equals 3. It can be flipped, right? Those things are flippable. X equals 3. So make sure, I'm sorry about that. So 27 divided by 9, you're going to, 27 equals 9x here, came down from this statement. We divide both sides by 9. It disappears from the right because 9 over 9 is 1. You're left with x. X equals 27 divided by 9 is 3. And we can flip it and say x equals 3, and therefore select this one. Make sure you are matching up the title of this video with the title of the problem set you're doing. It's Algebra 1, Semester 2. It's the 5th unit called Equations Review, and it's the 7th lesson called Variables on Both Sides of the Equation Practice, and it's on creatormath.com under the Algebra 1 tab. Hope this helps.